All right.
I'm not
All right, we're just going to go in order. There's a few that we need to get to other ones, like number 5 we're going to do, and that is contingent on 10 and 19, for example. But we're just going to hit some different ones, and they kind of become more or less, more complicated as we go. So if you're wanting to do this on a separate sheet or just on the side, that's fine. There's a lot of examples, guys, and a lot of things that you can utilize. I'm not going to repeat every single thing. So let's do 2C for an example. So it says write the equilibrium expression for each of the following reactions. So right away, I'm not going to do all of it, but this is where you should be beginning. If you don't know what that means, it's going to be hard for you. Like last chapter, what is the expression? And if you're wondering about the tests, I can't give them back yet. I just have to post the scores on. Anyway, it's okay.
Somebody's still not thinking.
So when we're doing these, you got to remember that you can only have things that can alter in a concentration of some sort. So it's a ratio, a pressure can be considered the same way. So in this case, for C, this one's a little trickier. That's why I picked this one. It should look something like that. If I did that right, which I did.
What would you put on top? One? Oh, I didn't see that. I looked up before.
That's right. If it's the other way around and the products are the only ones that are AQ or gases and the reactants are solids, then it would just be the values with nothing underneath. Okay? So you could go through all those. Again, the answers are on the back packet. You can check a lot of them, but there will be a few questions. Just, hey, write the expression. It won't be many, but just do you understand that or not? Moving on. Let's go to 3B. So one more type. So give me that one as well. And then we'll move on to bigger and better things. A great question would be, well, is it a KP or a KC? If they don't tell you, then it's always a KC. That's the default. And you do need to understand that. 'Cause it's like, well, why don't they do it like that? It's just the way it's done. The default is concentration. They have to go out of their way to say a KP then. So that's an important step as well. But what did I mention? B. You could definitely do a P if you'd like, but I didn't say specifics, so I'm assuming in the back as well it has the exact same thing. This is a good one because it really, if you can do this and get all the numbers right and you're choosing the correct ones, you're good. So there I go. Hey, Ms. Renz. I do have a whole crew. You want to just recap?
Yeah.
I can run over there. Are you going to be here a while?
Yeah.
Okay. Sounds good.
Well, no.
He just left.
So there you go. You don't use the liquid. You got to make sure that the exponents are utilized. Okay? All right. So we're going to have to use 5 for some other things. So here we go. It says calculate. So we will need a calculator. The equilibrium constant K for the reaction below. If the equilibrium expressions are those things. Okay? So I'm not going to say anything else. Just there you go. I don't need an actual setup. I would probably write out at least the numbers, but get that started. Let's get a K value. So if your answer has 3, that's okay because it's plus or minus 1 away, but looking at the answer or the problems, they all have 2 sig figs. That's kind of where I'm going off of on that. Answer should be in the back if you want to check it before I get there. be honest, this could definitely mess you up. If you don't like to use a lot of parentheses, then guys, you take this number, divide it over that, and then you just hit divide again. You don't have to hit multiply, you can hit divide again. It's actually a smart way to go about it if you're a little uncomfortable with how your calculator does parentheses. Like when I'm on a graphing calculator, I'm fine because I can visually see it all. And some of these, I know like these you can kind of see it on the top, but ones that make it disappear and you're not able to see it completely, you're in trouble. Hey, Lori, you found your calculator.
Yeah, it's in my backpack. Put it in a different pocket than I usually do.
I get it. What do you get? Okay, what'd you get?
1.6 times 10 to the 12.
Okay. Not for me, is that right?
Yeah.
Wait, we need that because we're gonna go to 10. So this is a legitimate kind of test question. I'm gonna see if you understand some mathematical tweaking of equilibrium expressions. So 10's in the upper right on your sheet. It says, given your answer from problem 5, wow, I pre-planned that. Calculate the value for K for each of the following reactions. All right, so instead of replugging all this in, which you could, like how do you do that? Well, you take your values now and then you put in new exponents. But we don't necessarily need to do it like that because we could go at it in a different way. So let's do a couple of these. And what I'm going to do, because they are all linked to the same one, this is a good way, this is kind of the accepted way to go about doing it because you are answering it based off of an initial amount. So it is not right or wrong. Like this should not be a stress for you, but technically if I'm going off of an original K and then they're all within one problem, like my first answer would be K prime, double prime, triple prime. If you just did K, it's not the end of the world, although if you are solving for a different K, you should probably have at least a K prime because you can't have K equals something with K. So, what if I asked you a generalized thing? Like, I didn't give you a value. Like, I just want to know what is it generically in terms of K. So let's just talk about that first one. What is up with that first reaction equation compared to number 5? Oh, jeez. Of course, it's one that we've never covered. It's a fourth, right? So, what would that look like? You could do this a couple ways. So, like when we cut it in half, what did we do? Take square root, which is really just to the half power, right? So you could take it like this. True? Is it flipped or is it not? Is it the same order still? I don't want to make that mistake. So, okay. Or actually, I'm feeling good about this. Is that not if you have that button? A lot of you, if you're like, whoa, whoa, whoa. There's a button that does this. If you know where that is, what you do, for many of you, you got to hit the 4 first, then that, and then your value. All I'm trying to say is that you could, then you'd actually have to plug it in. You'd have to put the 1.6 times 10 second, 12, not second. But what if, so these are all the different options. What if I didn't give you a value and I just said, what is the relationship just using K instead of a number? You should still be able to show it, and that's why you need a K prime, because you can't have 2 Ks in the same problem. You got to have a version of it. Okay, so I know that wasn't one in our notes, but it's the same idea, and it still would work. So those are all your options. The last two are exactly the same. I'm just showing you the button. Not everybody knows where that button is, or I remember one calculator, it was like under 3 layers worth of, and it's just like it wasn't even worth it. You just do the caret with a parenthesis 1/4 or 0.25 or whatever. 2/3 triangle or whatever. So try to figure out what the other two are, please. What are B and C? Like what happens to those, please? Basically, once we know a K, we should know the relationships or the relationships of how the products and reactants and their exponents, how they affect the original K. Mom?
I just have a different question.
Yeah.
Like for 5,
Yeah.
it's about pressure. So I give you units. Like on the test, are we gonna have to include units for that?
No, you do not need to do, no. You do not need units in your K. I'm curious though if they did K.
They all end up crossing over.
I didn't look at that very close. I just saw the number. I wasn't looking at it all. Yeah. Guys, I put in the numbers. Okay, this isn't wrong. It's asking for a number. So I just want to be really clear. So we are clear on this. Because they were pressures, technically it's probably a KP. I didn't ask for the expression. If I asked for the expression, I mean, putting in numbers are just numbers. If I had asked for the expression on 5, you should have then written, because they were given as pressures. What is this? Is this NO2? Like the top one? I just want to do one of them. Is that NO? Yeah. Like that, and then so on and so forth. Whatever these are. Well, let me just do it. Is it I think it's NO. If I asked for just the expression, that's actually what would have to have been written, because it was given in pressures. But the values here, and I don't need units because a lot of times the final answer cancels out anyway, and it's been stated a while ago that just it doesn't really matter what it is because you don't do anything more with it.
Right, but like that one doesn't.
I don't need the units in there. No. If I'm doing a icebox, you should just have the unit one time just so you're stating what you're using. But no, you don't technically need them in there, right? Which is weird. I know it's weird because I've been harping for the last year and a half for all of you that had me for a year and a half. But hopefully the other teacher as well said it. But should have units. And all of a sudden it's like, no. What do we do with the second one? Brody, what do you do with the second one? Did you get to it? All right, just listening to the great Jeffrey.
Oh, for the second one, I got 6.3 times 10.
What did you do to it?
Oh, I did 1 over K.
Okay, good.
We're supposed to find the other.
Right, because it's flipped. What?
I was wondering if we were supposed to find them.
Yeah, technically you are. I'm just showing you, like, if you
Yeah.
know this, then you're great.
Okay.
Yeah, I'm just asking for generic. You can plug it in. So, I mean, right, you do this. And then you get it. Yep. But again, I feel like if you know the K, then you can do anything. And then the last one, what do we do for that? Rory, what'd you do for that?
I put 1 over the square root of K.
Good, because it's flipped and it's halved, right? Good. To me, honestly, if I did a test, and even in high school, I would have done this. I had really good chem and math teachers that showed me to show steps. Like, I want to show this first, then I would have written like this. And I think a lot of you, I'm actually really happy to see a lot of you write it like this. Like, you show the steps. Like, I think it's important to do it, but it's your call. As long as you're getting that. It does not ask for that part, but.
Do you want to rationalize?
What a rational is.
14. I hope one day, like, human civilization is like, I hope not, I'm saying, is like about to crumble and like, I don't know, some other species like finds like some random video and it's like just the audio of like one of our reviews for our test and like, oh, this interaction between these humans and there's phone calls and people with parents. It's like, you know, they're gonna be really confused.
Let me know when they're searching for KC or like KP.
And that's kind of what I was stating here, and I rushed. I did not look at it very carefully. They gave everything in ATM. So if it was in moles or molarity, then it's KC.
Oh,
If in the beginning, Jeffrey, like the first 3, 1, 2, and 3, they don't say anything, so there's no numbers, then I'm just probably looking for just K, so that's a KC is the default.
okay.
Okay? Ready?
Isn't that supposed to be 1.6 times 10 to the 12? That's 6.8 down towards BC.
Yes. What is happening? Where did I even send it? I don't know.
That's how it's confused.
Okay, here we go. I got many more, but they'll start flying through here. The association of acetic acid has an equilibrium constant of 1.8 times 10 to the -5th. The equilibrium concentration of acetic is 0.46 moles at 0.5 liters of water, and that of the one of the ions is that many moles in the same liters. Calculate the concentration for H plus in the reaction. Okay, so let's talk about that. It's about organization. Now, you may, I just writing this out. You got to ask Jeff when you need to do an icebox and when don't you. In this case, I mean, sometimes it's about organizing it all. They've given me everything at equilibrium except for one thing, and they've given me the K. So in all honesty, like, I don't need to figure out what's changed or anything else because I don't know the initial. So honest, like, I don't need an icebox. I'm just going to write it here under E because I have, now, It's really important. When you have a K, it means it's with concentration. So you can't just write moles. When you're going to plug it into an equilibrium expression, you need molarity. So they did not do you a favor. They did 0.5 liters. So just got to make sure I get this right. So this is going to be now, and if you want to show the work on the first one or whatever, and you feel a little more comfortable, you definitely can write it like this, and then write it. It's your call, but you should have that, and then so well, my brain's not working. 1.62 times 10 to the negative second, I believe. Am I wrong? Anybody? I'm not functioning on all cylinders at the moment, apparently. And then I just need to plug it in. And the reason why I'm like, wait, why didn't you know it needed an icebox? Because, again, it didn't give me an initial amount. An icebox is talking about you have some amounts, and then a shift has occurred. And now I need to make that new calculation one way or the other. I'm given everything in equilibrium, including the K, except for one thing. So this is just algebra. Like, I just need to plug this all in now. So this is just, and this is why I wanted to show you this one. Like, skipping a couple steps of writing it out first. Here's my K, and then what it is, it's products over reactants. And then I just find my X.
So then why did you draw X?
I just wanted to show you like that I'm writing it on the E. I didn't really draw it all the way. I'm just trying to show you like it's already on the E. Like I've made it all the way down there. And the question wasn't like how much did I start with or anything like that. Bless you. So sometimes you just got to take a step back and be like, wait a minute. If you know everything, they keep giving you everything at equilibrium, there's probably not a lot of calculations you need to do. It's when they start giving you stuff in different locations. Hey, this is at initial, this is at equilibrium. Okay, now that's confusing. Like if they give me initial amounts and a K, K is about equilibrium, initial is not at equilibrium. So we need to calculate that, and hopefully it matches up with what's on the back. I hope. Look what you get.
0.0032728. Good. Good.
Hey, what'd you get? You're frowning at him through me. That's what I got. Well, only because I'm looking at the back.
What did you get? Oh,
It's a chance calculator. 1.0 times 10 negative third.
okay, that'd be the same. How do you get it to so it, actually you probably don't know. Everything's in scientific notation.
Why wouldn't I know?
You know,
Not a good question. That was a bad question.
like, you know what I mean?
Yep. Mode. It's supposed to be in radiant. I see radiant.
No, radiant's not good. Then hit enter again.
I think I'm in radiant
You
sometimes.
can't see it.
Yeah. Oh, yeah.
Why does that?
Yeah, that's what I got too. 0.00102. So that's 1 times 1.0 times 10 negative 2.
Do you want everything in scientific notation?
No, you don't have to.
Oh, okay.
But usually after you go a couple of decimal places past, it's a wise decision.
I don't know.
All right.
Wait, Luke, what'd you get?
Doesn't matter what Luke got. This is what it is.
Is it 1 times 10 to the negative?
All right, 19.
Good.
If you have questions, just shout them out. That's what this is about. It's not me just doing new lectures. It's if you don't get something, ask where I got a number from or whatever else. It's kind of the whole point. 19. Whoops. Oh, yeah. Derive an expression that relates K to Kp and calculate the value of K at 25 from the reaction given in problem 5. So, in problem 5, what is that? Now it really does matter. Is that a K or a Kp? What do we say? KC or KP?
KP.
Okay. And we said Kp was, just remind me, that's the one I messed up on, I believe. Positive, like that. So, this used to be on your yellow sheet. And I think I've been very fair all year, is if something's not on the yellow sheet, it's probably not something you have to memorize for May. Okay? So, you'll be given this. And I panic a little bit because I sometimes kind of mess up memorizing things. So there we go. So what I want to do is get K. So you're gonna have to look, I want you to try to figure this out right now. Do the best you can. Plug it in at least. At least plug all the values in. Can you at least get the numbers correct within the problem?
What is N moles? Oh.
Yeah, N is, I'll tell you that, yes, N is moles. At least plug it in. The answer is not that big a deal. Can you get all the numbers I'm about to write? Well, no, it's gonna be the gas one, so it's, usually we try to use the ATM, so it'll be 0.0821. Yep. And again, that will be on your yellow sheet.
Oh, it gave me.
What'd you say? Okay.
What is my change in N? -1. Reason why, and I don't have it in front right here, but you had 2 moles for the products minus 3 moles for the reactants. You got to look at problem 5. The 2's in the front, and then there's 3 on the left side. So it's -1. Please be mindful when you calculate this, guys. I messed this up the other day in class. You got to multiply both of these first, then take it to the -1. You can't just take 298 to the -1. And then you divide it under on the other side, and then you get your K. So, really important. Make sure that the N is the biggest deal to me in that part. Like, that's the one that you be like, can't remember this. I can't help you then. Can't help you on the test. Like, well, let me show you how to do that. You need to know how to do the change in N.
Oh, I didn't. I did that to the other one. I put that, and then.
All right, 25. These go quick.
I used too many parentheses for this. As long as they work.
Says the reaction of methane with water is given by the following equation. They give you the whole equation, K equals 5.67. Predict the direction that the system will shift in order to reach equilibrium given the following initial values of Q. Okay, these are the initial. And if you get confused, wait, initial. Q is the moment wherever you're at. And what Q tells me then is how the reaction is going to move forward from that exact moment. And it's always in reference to K. So right now, all it is an interpretation. If you want to write the word left, right, or it stays the same, or if you want to do arrows left or right, or an equal sign, please tell me how that's going to shift. You didn't have to do any calculations. So this isn't a very complex problem. It's either do you understand Q and K, or don't you understand Q and K? And if you don't, this is a good problem to work on. Caleb, what is A going to do if my Q is that and my K is that?
Shift to the right. Left.
Good try though.
Hey, Caleb, this is hard.
Caleb, how is it going to shift if Q is 11.85 and K is 5.67?
It's gonna shift to the right.
Good job. It's going to shift to the left. Because what you can do is literally place... Oh, come on. You imagine your 11.85 here. On this side, it has to come back this way. It's got to come back towards the number. You got to view it as a number line. So it's going to shift back to it. B, Rory, where is that going to shift?
To the right.
It's going to shift to the right. It is less than the number, so it's got to shift to the right. Adam, what's it going to do for letter C? It's going to stay the same. It's equal or no shift, however you want to think about it. There's no shift. We are already at equilibrium. It might be there. You might already be at equilibrium. So you just understand, you got to visually put K just in the middle of your vision and then just place Q on the left or the right or in the middle. That's all that means.
Wait, can you say like the left or the right? Can you say that?
Yeah.
Okay.
Actually, that's better. The arrows aren't really good. Like, that's all you write. It's
Okay, yeah, I didn't.
I'd say shifts to the left, shifts to the, like if it's on an actual test. So that's what I would do. Hello? Here we go, 33.
A little late there, bud. A lot of late.
Gotta recount it.
He's been embezzling.
I just show them the pockets.
That was, did you really?
No.
They count it with like just a swimsuit on. So, there's no- And once again, recording.
Okay.
33!
I just said it louder.
Hypochromous acid dissociates in water according to the following equation. Calculate change in H, or sorry, concentration of H of a solution originally 1.25 molar in HOBr. So it's a little, I picked this one because I thought the wording was a little interesting. And how do you go about doing this? So here we go. This you'll want to write out. So this is how they give it to you. This is going to be your life basically again for the next month and a half or so. So let's get used to it. You'll like that when we do acids and bases, we don't really worry a lot about coefficients and stuff. Everything's almost a 1-to-1, so that makes life actually a lot easier. So now we need to plug things in, and we get a couple other opportunities. So, but not too many. Actually, I'm going to let you for a moment fill in as much as you think you can fill in. If you don't know what to do, I'll just give you like 30 seconds. What can you fill in? Try to interpret what's being said. Again, we have to make assumptions. It's an uncomfortable thing. I have to make an assumption that this isn't present, or that this is, or that that is initial, or that is an equilibrium. There's usually just enough information that's given to me, though. Ski, give me one thing that you know.
HOBr for the initial is 1.25.
Good. And you don't necessarily have to do it. I like putting units one time so I've established what the heck I'm using. Okay? Luke, give me something else you know, or you think you know.
OBr minus is 0
For initial?
for initial.
All right. Hunter, what else do you know?
H plus is 0 for initial.
Okay. It's like it didn't say that. Correct. And it didn't, yeah, there you go. Exactly. It will state what is there, and that's it. So you can't be such a literal person and be like, but it didn't say all the other things. Yeah, it didn't. So we should know the shift and everything else. So hopefully you filled in more things. So I can keep asking people, like, where did it all go? This is not a necessity. But in the beginning, I like to do that just as we're learning this. I know it's shifting to the right. And the reason why is that it has to create something that's not present. They're all 1-to-1s, so that's not a huge issue for me. It's not something where I have a coefficient, so then I have to put a 2 or whatever else. So then I have this relationship. And if you don't feel like this is important, it is. As we go through this more and more, I'm amazed how many people will not do an icebox when I'll literally say all you had to do was an icebox and everything would have been organized for you. Like you'll lose it next chapter, else people will stop doing iceboxes. Be like, you got to keep doing the iceboxes. So we plug it in, kind of start to the left. My goal is always to make one last line here. So like if I do an icebox, I also don't need to make it huge. I watched some people on my notes, I think yesterday, and they made the icebox like way too big. It's like, what else are we expecting to put in there? Like we aren't putting, like even that's probably bigger than it needs to be. Because it's about the work then. This is just about organizing. So I have that, and then simply put. And if you want to consolidate that right away, some of you are like, I'm putting x squared on top. Great, do it. Next chapter is going to be like your life, like this. You're living right here. That's x squared over the initial minus x. Like that's where we're living. That's what we're going to take acids and dissociate them, like every time. Boom, boom, boom.
Take X's, like one X on each side.
Right. You mean crossing out then?
Yeah.
Right. So then, see. So if I just consolidate this first off, you got to be careful. You can't. You need nx when you're done. I think I showed that either was it today or yesterday. Like you can't cross them all out or else you're in trouble. But we cross out the x's that are subtracted or added, even if this is not in here. If that's a 2, it's still being subtracted. I can cross it out because this x, and you don't have to write this. Sorry, not that x. Oh. This initial amount is 100 times greater than the k. So the amount of error that this is going to create numerically from the calculation is going to be so minimal that it won't matter. And we'll talk about it later. It's called the 5% rule.
How do you know that it's 100 times greater?
Because that's 100 times greater.
Oh, okay.
then you can't cross it out. This chapter, I'm going to make sure that that is not the issue. We will get there, because then quadratic might have to come into play. And we're going to, just due to time right now, we're going to focus on one thing at a time. Jeffrey?
We do that on the top too, if there's an X.
Yes. But this is not being subtracted or added. So that stays. Okay? So now,
Are you just crossing that out because that number is so small?
well, whatever x is going to be, because the initial amount is over 100 times greater, is that whatever this value is going to be is not going to affect this so greatly that it will ruin our final answers.
So if K was bigger, you need to leave it there.
Then, yes.
Okay, gotcha.
But for right now, we're going to live in the area that, right now, we can cross out x's that are added or subtracted. Okay? Eventually, you're going to have to think about that. If that makes sense. What's the final question? Calculate h. That's all I want. So h is x. Here we go. Check this out. Next chapter, you're going to do this. Save yourself some time. Think about this. X equals h plus, correct? Why not write it once? It's pretty. It's condensed. See, because x is right here. So that's what I want. It's asking what is the concentration of x. So if I solve for x, I also solve for h plus. And I can give one answer at one time.
First question.
And when you get it, you can check the back, or you can just wait for a minute. And we just have a few more, a bunch of multiple choice ones that we're going to apply through to. Is the back right? Is that, it should be. There have been times it's not.
Wait, is it 4 point?
Too many sixes.
Do I have to put an M? Technically not. Why don't I have to put an M technically?
Because it's still K.
The bracket? I like doing it anyway. I guess I'll say this. People have asked, is it a double negative? Like, is it molarity squared? No, it's not. Like, it's still okay. I'd rather put a number, but you have established that's concentration.
Don't you just, what do you call it? Oh, it's over 1.25. Gotcha. Never mind. Yeah.
I love
forgot
our
why they're
talks.
1.25.
All right,
Okay.
here we go. 39. The equilibrium constant for the reaction blank at 448 is 40. Uh-oh. We'll get as far as we can. This is not, why am I saying uh-oh? Yeah, it's a large K, but we're going to live in a certain world for now because we have to make a decision at some point. Right now, it's more about the big picture for me. It says, what are the equilibrium constants of, of each of those? Now, I don't want to do every one of them, but let's get going and just get the setup. To me, it's more about the setup this first time through. Although it's easier not having coefficients, I kind of like having problems with that because then it tests us to see if we are completely doing this correctly. I guess from the teacher's point of view. Please try to fill that one out. Just fill out the box. And it's an organizational tool. It's not the final thing. People have in the past on tests, I will say, fill out ice boxes and then move on. They're like, yo, like, got it. It's like, you haven't started it. Like, you just organized your information. The word. Good start. You do a quote from the song. So cold, so cold. What is this? I've had this happen too. Some of you are thinking like, I get it. I know what that would have been. I can just plug it into an expression. You need to understand that this is work. Again, this is actually substituting, did I mess up something?
Yeah, SBCO 3 is not. It's 0.18.
SBCO.
It's SBCO.
Oh, thank you, that is a big deal. Wow, that's a huge deal. Wow, that was,
Wait, why did the,
I wrote it down wrong, Cory.
how do you, no, how do you know if it's negative or positive?
Because it's this way.
Because where the zero is, it's gotta go
Oh,
make
'cause
more of it.
Okay, I forgot.
Thank you, so, I wish I could say I did that on purpose, but it shows something really important. If you read it too quickly, it might not be given in the right order or anything else. Everything changes. Just going back quickly on my other statement though as well, this is work. This is actually substituting for more complicated stoichiometric relationships. And if you're like, well, how much more difficult can it be? You'd have to show different relationships and T-charts and all that. It's all taken care of by a simple initial change to equilibrium. Work.
So if it doesn't tell you like what the initial is, you can just say it's 0.
Right, so in the last problem, or a problem a little while ago, I said if they don't give you something, it's not like, well, how do I assume it's 0? They're telling you what you have, so they don't tell you that you have it, then you don't have it.
Okay, so they'll never say like find the initial amount.
Well, they could.
Or
But if they don't
you,
talk-
if you already have the, like if they.
We did a problem today, problem number 5 in lesson
Really?
17, that you had to find the initial amount. I made it Y,
Okay, gotcha.
which I don't think you were.
No, but.
Yeah, no, use mine, that's
So,
fine.
Yeah, every problem's going to be a little.
Trying to
Okay, very good.
Nothing.
Setup.
We just took notes.
Here's the problem. Technically, right now, we have to get this into a quadratic, and we don't have the time to start doing this. And I'm telling you, we will get into this, but we can't. If you solve for this, we can. We can definitely solve for this. It will not be the answer that's in the back. And actually, it'd be kind of interesting for you to see how far off it's going to be, because this right here, this one needs to be 100 times greater, and it's not. It's smaller. So the degree of error would be great when you solve for this, and it will not be accurate at all. So we're actually, again, you want to solve for it, and you want to cross these out, this is not correct. You can't be crossing that out. If you want to cross that out and solve for x and plug each one in, you can just see if you're doing it right just based on the SBCL3. You'll see that the answers will be greatly different from the answer in the back, because there's too much error, okay? But again, we're not going to get into that right now. And then what you got, plus or minus, is it b, is it plus, or negative b plus or minus square root of 4a, something minus 4ac. B squared minus 4ac, right. And all that.
Over 2a.
Yes.
Yeah, no square root.
Yeah.
For a fraction, would it be that way or would it be flipped over if the positive x is on the
Right, I'm glad you brought that up. So Katie asked, well, wait a minute. And this is where you guys start to overthink stuff. And I've brought it up a couple times, but every time you get a new situation, your brain tries to trick you on this. The fact that this is heading in this direction, you're like, oh, well, these are now my products and these are my reactants, so now I need to flip it. You need to understand that this K is always in terms of this being my product and this being my reactant. That is in terms of that. That's why when we flip an equation that you flip your K. It is always in terms of this. So even if it's going to the left or the right, the K is in terms of 40. So then it's just, if you have too much on the right or too much on the left, it will balance itself out. But this 40 is always saying that it's still, like, when it's 40, that's a really big number comparing to most of them. That means that it's not going to shift very far to the left. It's going to basically stay to the right. It's just going to make a little bit on this side, because we're already over here as an equilibrium expression. So it's not going to try to make too much on the left. If you get a ton on the left, it's going to try to flood it all to the right, because that's where the equilibrium actually lies. So don't start flipping stuff. The K is in the terms of the equation that you are given. So it's a good thing to bring up, because people do that a lot. You're overthinking it. You're trying to get tricky. Okay, so sorry, I didn't necessarily mean to bring that up for this problem. We're going to end right there, though, and just know that we would need quad. We would need ax squared plus bx plus c equals 0. And we will cross that bridge just due to the Monday not having class, and then I was gone for half the hour today. We're going to have to make a decision from now. Okay, a couple more. Can try to get you out of here by 4, like always. If you need to go, you can always go early. 41. Okay, so now, this is a little bit about Le Chatelier's. Now, maybe I don't cue you with that. It's a lot harder when a student's not told, according to Le Chatelier's principle. And I shouldn't have said that just now. So the following chemical process is at equilibrium. So there's an equation. How would the process respond if the pressure were increased? So if I'm increasing pressure, basically, which way does it shift? Okay, so I think volumes and pressures are the most difficult. Actually, I think the volume one is the hardest one. This is not a volume one. This just says pressure. So you got to think about this a little bit. Every equation is going to try to balance itself out. So if it's going to increase pressure, what's going to happen is the reaction will attempt to decrease pressure. How does it do it? So how do we decrease or increase pressure in a reaction like this? Remember? You could add or remove volume. Unfortunately with this, yes, we don't have that control. And we don't have that control either. The reaction has to happen right then. It says constant temperature.
Wouldn't they like shift the pressure over to the other side of the lower pressure to try to even it out?
What is lower pressure?
The one with less moles.
Ah, so how do you have more or less pressure? By having more or less gas. If you have less gas, you have less pressure. If you have more gas, you have more pressure. So if you look at that, and it's really important to look at this, in terms of moles, look at 41. It has 2 plus 1, and then this side has 2 for moles. Right? So this has 3 moles of gas. This has 2 moles of gas. So I want to decrease pressure, so this is going to shift to the, it's going to shift to the right. So you might want to really just jot something down. I'm telling you, these are the hardest ones. Now volume's even harder because if I say it increases volume, you got to do extra steps in your brain. I'm probably taking away a problem later, but I'm going to say it anyway, just in case. So if I increase volume, then you got to ask yourself, okay, what did that do to the volume? Or the pressure? It got bigger, so that means it's lower pressure. So now the reaction's going to try to increase the pressure. Like it's like multiple steps with volume. If it gives you pressure, it goes through it right away. And if you decrease volume, right, the pressure goes up because you make it smaller and all the particles make more collisions. All right, so I hope that one helps. I thought that was a really good question to go over. 42, and these are going to go kind of quick. The reaction of carbon disulfide with the chloride is as follows. Please tell me, and you can do arrows or say words, how do each of these shift? Predict the effect of the following changes to the system on the direction of equilibrium. You have 3 options. Shifts to the left, shifts to the right, no shift. Okay? So do A through C, please. If you want to check or talk about with someone else, you can. What happens with each? All right, let's. I know you might be finishing. Let's talk about it quickly. A, they're giving this away to you. Like they didn't need to say all this. It says pressure of the system is doubled by having the volume. I would have just, if I want to make this problem harder, I just say I have the volume or I reduce the volume. So right away they gave it away that the pressure doubled. So pressure went up. So we just had this last problem. It's going to try to reduce the pressure, so it shifts to the right again. That's just a coincidence. There's 4 moles here. There's 2 moles here. So it's going to shift to the right. And I'd actually write that. I'm just doing an arrow for speed here for me. CCl4 is removed as it is generated. So I'm taking this out as it's being made. I'm taking that out as it's being made. And it's like, wait a minute, that's confusing. As it's being generated, it's being removed. Yes, so it keeps like going back to 0. So what is the reaction going to try to do? What, Roy? Those are 2 of the 3 options. There you go. All right. What happens with Le Chatelier is when we remove things, shifts towards it, right? So maybe the wording's kind of confusing, but basically we're removing it, so the reaction's going to keep trying to create it.
So it'd be going to the right.
Correct.
Oh, okay, I thought you said left.
No, I just was waiting until Brody said all 3.
So I got it right.
Well, eventually you did, yes. Last one. Heat is added. All right, this one, a lot of students mess this up. Where am I looking? This. Specifically, if I'm on a test, it is negative, isn't it?
Yeah, yep, I noticed that.
I'm just going to remove this for a second. It's negative 238 kilojoules. What you need to do is physically, let's do it right now. Where does E go? Like if I had to put energy, is it on the left or on the right? Oops, I slid this over. It is on the right. And not because it's written on the right. Like, well, they wrote it on the right side. They will always write it on the right side. It's releasing, so energy's here. Once I place it there, I have made the problem about twice as easy because now I've created it or made it into a product or a reactant. Am I adding heat? Heat is added. So I'm literally thinking now, I'm adding my temperature. So what do? We shift away from the addition. So it's going to shift left. It's very important. If energy was positive, it's endothermic, that means you're adding energy over here. So that's why, like in your Le Chatelier's Labette, when you put it in heat, it moved away and made blue because blue was on this side. When you put it in cold, it turned pink because, and if you didn't do that yet, I'm sorry, I just gave that all away. So there you go. I think that was a really good one as well. Just have a couple more. We'll get there. These should go. They're all fast ones. Last couple. We can just talk about it all together. Here's a reaction. A, you triple the volume. Okay, you got to ask yourself, if I triple the volume, what am I doing to the pressure? And I'm not asking for a specific number, by the way. So I increase volume, meaning that I decrease pressure. So now you're thinking, okay, so it's going to try to increase the pressure. Like that's what the reaction is going to do. So I have to increase pressure by making more moles of gas. And that's going to go to the left. And that's also still a coincidence that they just keep having the larger number on the left and the smaller number on the right.
Wait, it would go to the left?
It goes to the left, shifts left because it wants to make...
Yeah. They just didn't add their numbers up or
You didn't add the numbers up wrong? The amount of nitrogen is doubled. So it's going to shift to the... It's going to shift to the right because what you're doing is you're adding something. So it's going to shift away from it. And then C. If I have this equation, arrow right here, the reaction arrow, where's my energy?
Left.
It's here, right? You gotta think that way. So I am adding energy again, and if I took it away, everything shifts towards it. If I put it and I add energy to it, it shifts away. So it should be shifting to the right because energy's on the left. Okay, hope that makes sense. Couple quick multiple choice and then you're out of here. If you have the time, I appreciate it. Like at this point, I've selected a few. Last couple. 47. When a reaction, this is just good. These could come up. I might even use a couple on the test. When a reaction has reached equilibrium blank, which one do you think it is? Actually, you know what? If you want to just quickly fly, I'll give you, these are the ones that we're going to do. There's 5 left. And they're all pretty short answers. I don't think I did any with calculations. I'll just double check that. And none of them have a calculation. I just kind of wanted to see what you can do on these. We will have a couple of multiple choice. We're going to start having multiple choices on every single test from now on because there's multiple choice on our test. 25% chance.
Well, 20%.
It'll be A through D. It used to be A through D. Now they do A through D.
Like that better.
It's like A through L. No. Just give me free response.
A too small.
Increase the yield mean?
Increase yield means, yield is just a reaction arrow, so yield would mean to make more of. And if it doesn't say anything else, then it's always assumed we're going to the right. If it doesn't say anything else.
Got it.
Yeah, that's kind of an interesting way to say it, though. I agree. Let's just get us started. I know you're working on other ones. 47. When a reaction has reached equilibrium, there's no E. D. Both reactants and products are formed continuously. Like they are now, and if you're like, well, I don't get that. Well, like letter A, it says no, nothing more is formed. It's always being formed. It's just now a constant rate. It's like with the buckets. Now you're constantly going. It's the same amount, so they're continuously being made. So all the other ones are, when you say passive, we haven't really used that terminology, so I wouldn't use it on the test, but that nothing's being done or it's not being active anymore. There's always activity. Always activity. 48. Which of the following changes will change the position of equilibrium? You're like, wait, it never changes. No, no, no. Equilibrium can shift. There's just a relationship called K. Anybody know that one? It is B. If you allow more time to pass, it's just going to stay at equilibrium. If you add a catalyst, it just goes faster and gets the equilibrium faster. But if you remove products, we talked about that with Le Chatelier's principle, it will shift towards the removal. So now there you have products and reactants in a different amount. You're changing the amounts. I'm not changing K, but I'm changing the amounts at equilibrium. Maybe that was the confusing part for you. 3 more, we're done. 64. For a certain reaction, Q is 2.33, K is 3.54. We already did one of these, I just want to do one more. It will proceed. And forward and backwards, forward just means to the right, backwards means to the left. We should know that kind of stuff. What is it? It will move forward because it's less. What is that, A? Right? You got to see it on a number line. That's how I see it, at least. You don't have to see it like that, but 70. Which of the following changes has no effect on the position of the equilibrium? So no effect. C, time. We're going to get there or not. Okay, so if you're at equilibrium, it doesn't matter. But if you change all those other things, you're going to be shifting. Think of it this way. If I ever ask you, how does it affect the equilibrium? It would be like Le Chatelier's. Any change, if it moves it left or right, that's changing equilibrium. That's what Le Chatelier's is. And then 72, final one. What would you change to increase the yield of the following reaction? So, oh, wait.
When's it kindly be?
If, sorry, and if you don't understand this, yield means to move forward. So to get it forward, you don't know anything about the temp, by the way. Temp doesn't work. Like, well, I'm going to talk about temp. It doesn't tell you about change in H, so you have no idea. If I want to move it to the right, it's going to make it so it makes more. Sorry, it's going to be less. Oh, there we go. So you got 1 mole of gas on the left, and you got 3 moles of gas on the right. This is a trick. The 4B is a solid, and the G is a solid. So the only way to make it go forward, that is a very dirty question. It is B, and I hope you see that why. You can only move it with the pressure from gases. And what was it, 1 and 2, I think? There's 1 mole on the left, 2 on the right. Right, the 4s and everything else didn't count. So, anyway, keep working on all your stuff. The lab is the only thing.